Okay, in this video, we're going to continue looking at function notation, but we're going to be determining domain or range based on having been given one of these with the function notation. So let's just take a look at a couple of examples. So here is the first one. It says, given the function f of x equals 5x minus 3, and the domain is -1, 0, 1, what is the range of the function? All right, so remember that this function f of x equals 5x minus 3 is another way of saying y equals 5x minus 3, okay? Well, in this problem, we know what the domain is. It is discrete domain. We're given three very specific x values, -1, 0, and 1. So what we're going to do is find the range. So think of in terms of a table. If we have a table of x and y values, we have the x and the y. We've been given the x. We have a -1, a 0, and a 1. What we are trying to determine is what are the corresponding, or what are the y values that go with each individual x value, and that will be our range. So we're going to use this function and we're going to plug it in, but we're going to find, remember y is here, it's a function of x, so we're going to find a function of -1, or f of -1, using this equation, and we're going to find f of 0 and f of 1. So let's start with -1, okay? We're going to find f of -1, and it's going to equal 5 times -1 minus 3. Now we just have to work this out. So 5 times -1 is -5. And -5 minus 3 is -8. So f of -1 is -8. So we're going to come over here and we're going to put -8. -8. All right. Now we're going to find f of 0. So we just work it out. F of 0 is going to equal 5, and then we input a 0. 5 times 0 minus 3. Well, 5 times 0 is 0, so now it's just 0 minus 3. And of course, 0 minus 3 equals -3. So therefore, f of 0 equals -3, or when you input a 0, you get an output of -3. So I'm going to come over here and write -3. All right, and then the last one is a domain of +1. So I'm going to write f of 1 is equal to 5. And then I'm going to plug in the 1. 5 times 1 minus 3. And of course, 5 times 1 is 5. So 5 minus 3 equals 2. So f of 1 equals 2. So I'm going to come over here and plug in a 2. Therefore, the range for this one is going to be -8, -3, and 2. All right. That is how you work with that one when you're given a discrete domain and the function. All right, let's take a look at another example. This says that we are given the function f of x equals 1/2 2x squared plus 6, and knowing that the domain is all real numbers greater than or equal to -3 and less than or equal to 2, what is the range of the function? So same thing, we're given a domain and we're trying to find the range. However, this is a continuous graph, continuous domain, so we're going to have to find the range that's going to be in this format as well. But let's think about it. If we know that we have the least value of the x value is a -3, and the greatest value is a 2, what we're looking for, we have a -3 and a 2, and each one of these is paired with what we are trying to determine, and we will use those numbers for the range. And remember that these are y values, okay? That's why we're looking for the range, okay? So we have our function f of x equals 1/2 times 2x squared plus 6. Now this might be one where it would be really nice to be able to use our calculator in order to plug this in and let it solve it for us. But basically we're going to plug in here for x, we're going to plug in the -3 and get the output, and we're going to plug in a 2. So let's start with the -3. So basically we are finding f of -3, and that's going to equal 1/2 parentheses 2, and then again times. Then I'm going to put -3, put that in parentheses and square it, plus 6. Okay. Please know that when you plug in a value here and it has to be squared, like a -3, we have to square that first. We can't multiply 2 times -3 and then square it. I put this x squared in parentheses so you know to square that first, okay? So here we go. I'll keep working this out. So we have 1/2 and then parentheses 2 times. Now I'm going to square -3. -3 times -3 is +9. You have learned how to work with those exponents or squared numbers. So 2 times 9, and then plus 6, and then our closed parentheses. So I'm just going to continue working this out. 1/2 times, and now it says 9 times 2, which is 18, plus 6. So 18 plus 6, so we'll work that out. 1/2 times, and let's see, 18 plus 6 is 24. So 1/2 of 24 is 12, okay? So one of the numbers we're going to be using in our inequality is 12, okay? All right, let's take a look at the other one, okay? So now we're going to find f of +2. We're going to bring this one down and plug it in. So f of 2 equals, so we're doing, again, 1/2 parentheses 2 times our x value, 2 squared, plus 6. Okay, we'll work that out. We have 1/2 times 2, and then 2 squared is 4, so that becomes 2 times 4, plus 6. We'll just keep working it out. 2 times 4 is 8. 8 plus 6. So 1/2 times 14. And then 1/2 of 14 is 7. So we have a value of 7 and 12. If these are the values that we're using that are our outputs, which are y, then we're going to have a range from the lowest to the highest, okay? So then we're writing our answer for the range. The range is going to be, remember we use y. We have our less than or equal to and less than or equal to. I know it's less than or equal to here because it was that way with the domain, so it can't really change. All right, and then we have a 7 and a 12. So we're going to go with our 7 and our 12. And that would be the range that goes with this domain. All right, and that will be our last example.